Imagine pouring a glass of water, setting it on the table, and watching as the water slowly crawls up the inside of the glass, spills over the edge, and pools onto the floor until the cup is completely empty. No pumps, no hidden wires, no camera tricks, just a liquid actively deciding to defy gravity. It looks like a glitch in the physics engine of our universe, but it is not a trick and it is not magic. It is completely real. What you are picturing is one of the most bizarre, mind-bending states of matter ever discovered. It is a phenomenon that shatters the everyday rules of physics, and it proves that the universe is far weirder than you could ever imagine. To understand how a liquid can flow uphill, we have to talk about friction. You interact with friction every single second of your life. It is the force that stops your car, the reason your shoes do not slip on the pavement, and the reason water eventually stops swirling in a glass after you stir it. In the world of liquids, friction is called viscosity. Honey has high viscosity. It is thick and stubborn. Water has low viscosity. It flows easily. But what if you could take a liquid and completely assassinate its viscosity? What if you could create a liquid with absolute zero friction? For a long time, physicists thought this was impossible, but then they started playing with extreme cold. And I do not mean Antarctica cold. I mean colder than the darkest, most isolated voids of deep space. We are talking about approaching absolute zero, the theoretical limit where all atomic movement simply stops. Enter helium. Yes, the exact same gas that makes balloons float and makes your voice sound like a cartoon character. But when you compress helium and cool it down to minus 269 degrees Celsius, it becomes a liquid. Liquid helium is already strange, but it still behaves mostly like a normal fluid. It bubbles, it boils, it obeys the law. But if you push it just a little bit further, cooling it to exactly minus 271.1 degrees Celsius, a temperature scientists ominously call the lambda point, something terrifyingly beautiful happens. If you watch a vat of liquid helium being cooled to this point, you will see it boiling violently. Bubbles are everywhere. And then, in a single fraction of a second, it goes perfectly eerily still. It becomes as smooth as glass. It stops being a normal liquid and transforms into a superfluid. This is where reality breaks, because a superfluid has zero viscosity, none. If you were to stir a cup of superfluid helium and come back a million years later, it would still be spinning with the exact same momentum. It would never, ever stop. But infinite whirlpools are just the beginning of the madness. Because it has zero friction, superfluid helium does not care about the physical barriers that contain it. The moment you put it in a cup, it begins a microscopic jailbreak. It spreads out into an infinitesimally thin layer, just a few atoms thick, and starts creeping up the walls of the container. It defies gravity, crawling up the inside of the glass, over the rim, and down the outside, dripping from the bottom until the glass is entirely empty. It is literally escaping. But it gets weirder. If you put superfluid helium inside a container with microscopic pores so incredibly tiny that not even a single drop of water or normal helium could ever squeeze through, the superfluid will just leak right through the solid material as if it is not even there. It treats a solid ceramic bowl the same way normal water treats a colander. So, how is this possible? Why does the universe allow this to happen? The answer lies in a realm of science that usually only applies to the invisible world of atoms, quantum mechanics. Normally, the atoms in a liquid are like a massive crowd of people rushing through a busy train station. They bump into each other, they bounce off the walls, they transfer energy. It is chaotic. That chaos is what causes friction. But when helium is cooled past that lambda point, the atoms lose so much energy that their individual identities begin to blur. They stop acting like billions of separate atoms and start acting like one single massive superatom. This is called a Bose-Einstein condensate. Instead of a chaotic crowd at a train station, the atoms become a synchronized marching band, all moving in perfect, unbreakable unison. Because they are all acting as one single quantum entity, there is no bumping, there is no resistance, there is no friction. You are quite literally watching quantum mechanics, the weirdest branch of physics, happening on a macroscopic scale, right in front of your eyes. But why should you care about a ridiculously dangerously cold liquid escaping from a cup, because understanding superfluids is unlocking the future of human technology. This exact same quantum synchronization is what makes superconductors possible, materials that can transmit electricity with absolutely zero energy loss. Imagine a world where the power grid never wastes a single watt of energy, where hyperfast magnetic levitation trains are cheap and everywhere, and where quantum computers can solve the world's most complex medical and environmental problems in seconds. The secrets to all of that are hiding inside the bizarre behavior of superfluids. We are standing on the edge of a new era of physics, peering into a world where the impossible becomes routine. Superfluids show us that when you push the universe to its absolute limits, it doesn't just shut down, it reveals a hidden code, a magical set of rules that we are only just beginning to understand. But as mind-blowing as zero friction is, what happens when we reverse the process? What happens when we push matter to the absolute highest temperatures in the universe? That involves a state of matter so violent it only exists inside the core of stars. And it is something we will explore in the next video.